Hello, in this video we're going to go through Learning Target 522, which is to use interest formulas in real-world problems. So we're going to talk about two types of interest today. One is compound interest and one is continuously compounded interest. And they have two different formulas, but they're essentially the same concept. So let's start by labeling all the pieces of our formula so we know what they mean. So A in both formulas is like the amount, so your total. And then P is the principal, which if you're not familiar with that word in this context, it just means like the initial amount. So if we're talking about like a bank account, then it's simply like your original amount that you put into the bank account. And then this is where things differ a little bit. So you always start with your principal, but then for compounding interest, it essentially means that like once a year or twice a year, they calculate the interest on your account. So however much you have in there, they'll give you an interest payment based on that. Or this can also just be like growth over time. So a lot of this has to do with like if the population is growing by 5%, we can use that in this formula as well. So you're always going to start with 1, which is your full amount, and you're either going to add for growth or subtract for decay. And then R is our rate. So our interest rate, growth rate, and then N is the number of times compounded. So if it says it compounds twice a year, that number will be 2. You only really have to worry about that if it compounds more than once a year. Otherwise, you don't have to. And then N up here stands for the same thing, and T is time. So if it compounds twice a year over 10 years, that you'd multiply those to get 20. The only difference with continuous is we use the letter E to represent the rate, and then our rate and our time are up here. So these stand for the same things. R is rate, and T is time. And you'll always know it's continuous because they will say it's continuously compounding. They have to say it in the problem. Now let's go ahead and look at some examples. And these are all going to be story problems, and you're going to have to decide what formula to use and where to put things. So it says, in 1981, the Australian humpback whale population was 350 and has decreased at a rate of about 4% each year since then. Write a function to model the population growth, and what will the population be after 10 years? So you kind of just want to read the problem to see what's going on, and then you want to look at a few things, and I like to label as I go. So it says the population was 350. That has to be P, our principal amount. That's the original amount. And then it says it's decreasing, so we're going to be subtracting our rate. And the rate is 4%. That's our R. And then it asks what will the population be after 10 years, so that's our time. So first thing I'm going to do is just write a function to model the population growth. So our function, we're just going to plug into our equation. So A equals, our principal amount is 350. And then it doesn't say it's compounding at any different rate. It just says 4% each year. So I don't even have to worry about the N part. You just imagine that's just an R and there's just a T. So we're going to do 1 and then we're decreasing by 4%, which is 0.04 as a decimal. You need to be able to convert percents to decimals. And then our function is just going to have T for time, but then we're going to use the 10 years after that. So this is our function to model the growth. Then to find after 10 years, I just have to plug in a 10 for that T. And you can type this whole thing into your calculator just as it is, or you can simplify it in pieces. It's really up to you. So we're going to do 350, 1 minus 0.04 to the 10th. And this is what we get, 232.69, which makes sense because it should be smaller than the original because we know we're decreasing. Why don't you go ahead and pause it and do the U-try and then push play when you're ready to see the answer. Alright, and this one you should get an answer of 310.27. You can see where I labeled my values and plugged them in. Now let's look at one that's compounding. So this says Brenda invests $4,848 in a savings account with a fixed annual interest rate of 5%, compounded twice per year. What will the account balance be after 6 years? So we know that this is what she invested. That's our principal amount. This is our rate. But then it says it compounds twice per year. That's your N. If it tells you a different amount besides once, that's going to be your N. And then here's our time. So we're going to use the same formula, but now we have to include that N. So A equals our principal amount. And then whenever it's interest, you're gaining. So we're going to be adding. Our rate is 0.05. And then it's a fraction over the N value, and our N is twice. N also shows up in the exponent. It's twice and 6, so you can write it like 2 times 6, or you can do that math in your head before you write it down. And then again, you can just type this as it is. You just have to make sure you simplify this fraction. Either put it in parentheses when you type it or simplify it first. So I'm just going to type the whole thing in my calculator. So we have our principal amount, 1 plus, I'm going to put that fraction in parentheses, to the 12th power. And we get this amount, 6,520.02. And again, that makes sense because we should have more money in our account. So pause the video, do the next problem, push play when you're ready to see the answer. And here we go. Again, you can see where I labeled my values, plugged them all in, and we should get $4.8832. Now let's look at this last one. This is a continuous example. So if you invested $3,500 in a savings account that compounds continuously, every time I see continuously, I just underline it, or sometimes I'll even put it in a box to like draw attention to it because I have to use a different formula for that one. At a rate of 9.73%, how much would you have in 8 years? So again, we have our principal amount, our rate, and our time, but we're using a different formula. This time it's our principal, and then E and R and T are in the exponent. So set up like this where they're being multiplied. And again, you can just type that in your calculator as it is. You have an E to the X button right here, so you can do your second and then E to the X, and it will take you right to the exponent, so you can type in your rate and your time. And I just do it like this where they're being multiplied. I don't have to simplify before or anything. And so we get $7,622.95. All right, last one. Pause the video, do the problem, and then come back to see the answer. And here we go. So I have everything labeled. This one again says continuously, so I need to use my continuous formula, and we should get $40,828.29.